We are discussing the our subject name is industrial instrumentation. Industrial instrumentation. This we are discussing the pressure measurement. In this topic, we have completed up to diaphragm. Diaphragm. We have also completed working of metallic diaphragm. So this since the elastic limit has to be maintained, deflection of diaphragm must be kept restricted in manner. So this can be done by cascading metallic, cascading the many diaphragm capsules in shown figure. There is many capsules are cascaded here to form a metallic diaphragm. So that it can take the more high value of pressures, because we have previously seen that single diaphragm can handle by very small pressures. Then compared to this metallic diaphragm, it can be handle more pressures because it is made using uh, different using more than one capsules. So this is the construction of the diaphragm. The man This is the main capsule is designed by joining two diaphragm at peripherally. A pressure inlet is provided at the central position. This is the central positions. When pressure enters on the capsules, it deflects. It deflects. When pressure enters on capsules, a deflection will be sum of all deflections of all individual capsules, because more than one individual capsules are connected here, and the combination of all individuals pressures, they can aid the in total pressures, and then according to this it will produce a deflection. That's why this diaphragm will be able to measure more and more pressure. So this will also deflect the lever connections. We have studied, we discussed the lever can throw the pivot our previous lectures. The throw pivots movements this transfer into the scaling mechanism. Next we will discuss them, because already we have discussed this study in our classes. So we will discuss some advantage, disadvantage. What is the advantage of metal? Advantage of metal diaphragms. So this is the best advantage. Their cost is less. दूसरा, they have linear scales up to wide range, because this when means this here is a pressure, here is a displacement. When we apply the pressure and pressure more, displacement will occur. No permanent zero shift is here. Means if the reading be constant years, it will not. Suppose that here zero is there, here is one. So this if the pressure we are increasing, this it will move increasing region. No permanent zero shift is here. What is the disadvantage of elastic diaphragms? Shocks and vibration affects their performance. Hence, they are to be protected. No, you can come. Then we will discuss about the working principle of bellows. Bellows is also used for measurement of pressures. So what is the like a diaphragm, bellows also used for measurement of pressures. Bellows also can use measurement of pressures, and that can be made by cascading capsules. This is the made by cascading the capsule. Metallic diaphragm are made more than one capsule, but here that pressure cascading is not there. It is the made for cascading capsule. The basic way for manufacturing bellows is a very fastening together many individuals diaphragm. Below element basically is a piece of expansible, collapsible, and actually piece of expansible is the expansible, axially or flexible members. It has many convolutions or convolutions means folding or folding. It can be manufactured from a single piece of metal. So this is, we can see that this is the diagram Veloz pressure element. This is the Veloz. This diagram, Veloz diagram. Here you can see this is the Veloz element. This is the Veloz element here, and this is the springers. So bellows are connected. This is the like this. This bellows are here. Bellows are calculated. This diaphragms are like this. Diaphragm. Bellows element basically one piece extensible, collapsible and axially flexible. It has many conjugation diaphragms. This is the when pressures we are applying from here. So based on this, the link. This is the link pointer, and so diaphragm get and because of this, the pressure filled by this bellows, and this link pointer will deflect, and that reading we can use the. So construction we can see the bellows gauge contain elastic elements that is a convoluted or folded that unit of response to construct actually change pressure. The most bellows gauge are spring loaded. That's there are many spring loaded. With the spring loaded, you can see this is the spring loaded like this is these are the spring like this all the spring all loaded on that things. Most type are much spring loaded. The bellows gauge containing an elastic element that is convoluted unit of expand and construct actually with change in pressures. Most bellows gauge are spring loaded. The spring oppose that means why the spring because spring oppose the bellows thus preventing the full expansion of bellows. The limiting of expansion bellows it may protect the bellows and prolong its life. Means if spring that means spring is connected with the diaphragm, so that's permitted the maximum expandable of this bellows so that its life expectancy can be removed or it will not be damaged because of spring due to if the more pressure is applied. In a spring loaded bellows element, the deflection is a result of force acting on the bellows and opposing to the force. Spring. This movement of bellows is transferred to pointer through the links. Pointer through the links. Bellows can be also used to measure differential pressure. Two differential pressure can. For differential pressure we can use the bellows. For differential pressure we can use the. This is the gauge movement mechanism. This structures like this. Suppose this is like this in gauge movement, and here this like here this is moved on according to this gauge mechanism. This is the pointer and scale. This is the pointer and scales. When the pressure is applied on when the pressure is applied from here this side, and this is the pressure connections one another it different another pressure the atmosphere anything can be here according to this based, based on the pressures it will move, so we can find the pressure. Suppose that if more pressure is here, this will move like this, The more pressure is here, and this want to move like this. So based on this deflection, and we can find the differential pressures, this pressure from here, differential measurement. Constructions we have already seen. So bellows are used to measure the differential pressure. Which circuit we have already seen just now. That's bellows to measure the differential pressures. Differential pressure measure showing in the two different pressure applied to them, to the pressures connection. Scale and pointer is attached with gauges. Scale and pointer is attached with gauges at the center of bar. Bellows are connected between the input pressure and force valve. So working is very simple. When pressure is which pressure to be measured applied to outside inside the bellows. However, the practices the most bellows bellows or measuring devices have pressure applied to the outside bellows. As inlet pressure varies, the bellows will expand or contracts. Based on the pressures, bellows contract or express, and this will move in linkage assembly. This will move the linkage assembly. This will move the linkage and pointers on apply the pressure on scale. That means if we are applying the pressure on here, so based on applied pressure, this bellows must be contract or expand. Based on their contracts or expand, the link pointer link may be changed, or based on the change, its reading will be changed. So differential pressure, the reading will be changed. For differential pressure measurement, so on pointer and the linkage assembly pointer will show the applied pressure scales. Then next is the for differential pressure measuring using the bellows will try to imbalance the force, and accordingly this movement is transferred to the gauge. So like burdon tubes, so in differential pressure for differential pressure measurement using a bellows applied a differential pressure will try to imbalance the force. Accordingly, this movement transferred to scale gauge movement pointer. That means what we have discussed just previously. That pressure is applied here and here. So this will going imbalance. Based on this imbalance, the pointer will indicate its reading. So in this way, working is very simple. Like Verdant tube element, the elastic element bellows gauge are made of brass, phosphorus, stainless steel brim. So this is the material which is used, like brass, phosphorus, beryllium, so many materials is used. Although some bellows instruments can be designed for measuring the pressure up to 800 psi. Their primary application in the measurement of low pressure or small differential pressure. List of advantage of bellows. Advantage, disadvantage of bellows type pressure gauges. Bellows joints don't require access. They can direct worried, however, tolerates its recommendation. No maintenance is required, low cost. Can be used to measure differential pressures. Some advantages, list some advantage we can write. Bellows don't require access. Bellows joint don't require access. They can be so we are discussing the list of advantage of bellows. Well, no maintenance is required because this structures like this and structures like this. There is a so one generally it will not require more maintenance. More if it one time is broken, then we will require the maintenance. Cost is very low. They can be used for measuring differential pressure. This is the beauty of they can be used. This the question may be asked for MCQ. They can be used for measurement of differential pressures. Disadvantage: velocity joints falls in catastrophically. No in place maintenance or repairs can be performed. They are just replaced or damaged. A smaller pressure range is applicable. If disadvantage is pressure range is very small. Temperature compensator needed because of temperatures reading will change. That's what temperature compensator is. So next topic we will discuss about the strain gauge. Strain explain the working of strain gauge pressure transducers. Using the strain, how we can measure the pressures through which we can discuss. When force is applied to any metallic wire, when force is applied to any metallic wire, its length increases due to strain. Its length increases due to strain. The more its length increases, the more is applied force, the more is strain. More in increased length of wires. Means when force is applied to metallic wire, suppose that this is any metallic wire, working we first we should know the concept behind it. Suppose this is the metallic wire. This is the metallic. When force is applied to metallic wire, it suppose that it may be compressive, it may be tensile. Based on this, its length will change. It may be increased or it decrease length of wire. If the initial length of wire is L1, initial length of wire is L1, change length of wire is L2. This is the initial and this is the change in length is wire L2. L2 is the final length after the applications of the strain can be written. This the strain can be written final length minus initial length divided by initial. This is the strain, that is called it strain. Any wire, how the strain is generated after applying the force. Using this formula we can calculate. Further, the length of a straight wire is increased, its diameter will decrease. Suppose that this is the wire is there. If we increase its length from up to here, practically, so that its length is going to increase, but its diameter is going to reduce. So, if the length increasing, then diameter is reduced. So now we know that resistance of conductors is a inverse function of length, inverse function of conduct, and this resistance is R over rho L by E. Means if length is increasing, so resistance will increase. If the area is increased, area increase means diameter is increased, then area will also increase, then resistance will reduce. Here two factors. If the length is increasing, then resistance will increase. If the resistance increase, if the length increase, then diameter will reduce. Then diameter will reduce. If the diameter reduce, then area must be increased. In this way, we can calculate the change in resistance. So this change in resistance of conductor can be measured easily and calibrated against the applied force. Thus, a strain gauge can be used to measure the force, and related parameter like pressures, displacement, stress. Input and output relationship of strain gauge can be expressed by in terms of gauge factor or gauge gradients, which defined as the resistance of R is given by strain. So how the gauge factor will change? So when change in resistance, right now resistance will change. So generally gauge factor, we will discuss about the gauge factor. I think we have discussed it about delta R upon R upon into strain. And this is the generally gauge factor, because all things are interrelated, because length is changed, because of length is changed, so R is R is changed, diameter is changed, so A changed, again R is changed, so delta R is changed because of this delta R change. This is the delta. This is the ratio of delta R upon R, change in resistance to resistance to the strain, because of strain is changed. Strain is improved because length is going to change during this process. So the gauge factor we can write using this formula. Here is not written this formula. So already we have discussed in our transducer subject on how the gauge factor is like this. Gauge factor delta R divided by R into epsilon. In this way, gauge factor can be. The strain gauge can be measured to force and related parameter like pressure, displacement, and stress. All these parameters we can use in the stress. Input and output relations of strain gauge can be expressed by in terms of gauge factor or gauge gradient. Somewhere it's called a gauge gradient, some is called the gauge factors, which define change in resistance to given applied strains. Means which defined according to here not written which define change in resistance according to original resistance divide strain gauge. This is the gauge factor. This formula you should memorize for gauge factor. Here up to we have seen how a strain gauge is created and resistance can be measured using this. And next we will how we are measuring the temperature using the transducers. This, we are because we are discussing the industrial instrumentation. Industrial instrumentation. In here we will discuss how a strain gauge is used to measure the pressures, because until we have seen working of a strain gauge, and this is the also part of pressure transducer. This is the also part of the measuring of pressures in transducers. Next, we will discuss how the pressures can be measured using the strain gauge transducers. So we can see one circuit diagram here. This is the circuit diagram, strain gauge pressure measurement. This is the circuit diagram for strain gauge pressure measurement. This is the circuit diagram where here the process pressure is applied from here. Then this is the resistance. This is RG1, RG2, RG4. The RG1 and RG4 two resistance. These resistance are when pressure is applied, its resistance is increased. When and second two resistance, when pressure is applied, then RG2 and RG3 resistance going to stay. This is the constructions about the designing of, and all these resistance are placed on the where for electrical heat stone bridge. Suppose RG1 is connected here. This is the RG1 is connected here. Next is RG2 is connected here. Next is RG3 is connected here. Next is RG4 is connected here. In this way, we can see increasing resistance are connected in in opposite arms, and decreasing same body are connected in different arms. So right now we here one galvanometer is according to this galvanometer is connected here. If during the balance conditions there is no current flow through the galvanometer, if this circuit is bridge is not balanced, then the current will flow from the galvanometer. Then right now we will see the construction and working of this. So construction this figure what figure we have seen, the four strain gauge RG, R3, R4 are connected. Two strain RG and R4 are mounted, so that increasing the pressure, that increase the resistance. We have seen in our previous diagram here RG1, RG2 here, RG2, here is RG3, here is RG4, RG4, RG1, RG2, RG4, two strain gauge RG1. So these two four what we have discussed for mounting, increasing the pressure increase, that resistance will increase. Then second two strain gauge 2 and 3 are mounted, so thus increasing the pressure, decrease the resistance. This wire. Beauty of this RG, in case of RG1 and RG2, in case of RG1 we can see RG1. In RG1 and RG4, if the pressure is increased, then the resistance must be decreased. In case of R2, RG2 and RG23, the pressure is increased, the resistance must be decreased. So this is about the pressure decrease in resistance. A change in temperature affects all four strains in same way, resulting no change in pressure indications. Second, right now we have so this is the constructions. How this construction we have already seen. R1 is here. This is for increasing temperature. The pressure increase, their resistance must be, pressure increases, so these resistance must be increased. You should increase. For these two, R2 and R3, if the pressure is increases, their resistance must be decreased. So this is the construction, and in this, so next we will discuss about the working, how these instruments are working. 8 balance conditions. We have this is the or these are also put it in bridge. We have already discussed it. We don't have much more time, and we will discuss the next our 8 the balance condition. When 8 the balance, when there is no pressure. Suppose that initially that this bridge is the initially there is put it, but there is no pressure applied anywhere here. No pressure. There is no. So all these there is no pressure. So no current will flow from here. So no volt galvanometer will show the reading is 0, because at no pressure no current will flow here through the galvanometer. Hence, there will be no deflection. That no deflection shown in the galvanometer means no. When there is no current, then no deflection is shown. As soon as pressure is applied to the strain, as soon as pressure is applied to the strain gauge is stretched or compressed. According to state, it may be compressed or it may be stretched. According to then, the bridge circuit is going to unbalance due to change in their resistance of strain gauges, because the pressure is applied. So R3 we have discussed already. R3 and R1 are the resistance going to increase, and R3 and R2 the resistance going to decrease. The pressure is going to increase. So because of this bridge is going to imbalance. Because of this bridge going to imbalance, and the reading will be shown here, and the reading of galvanometer will be changed. And at the up to balance condition, when there is no force pressure applied on this pressure gauge pressures diaphragms, then the reading was the 0. Right now pressure applied R1 and R2, R3 value all will be changed. So then the reading of the galvanometer will change. The reading of galvanometer will change, because due to different this change after the output bridge circuits indicate that change in measured pressure. Now the change in voltage may be calibrated in terms of pressure. So this is the working of the strain gauge, how the strain gauge pressure transducers is work. List advantage and disadvantage of strain gauge pressure transducers. What are the advantages? Well, no moving part is there. All part are fixed. R1 is fixed. No moving part. Small छोटा है, small and expensive है, not too much costly. Is only resistance are required, strain gauge resistance. Fast response, because response to, if we are applying pressure, then resistance and changes, based on that we can calibrate it in terms of current reading of galvanometer to pressures, because current reading of the galvanometer change because of applied the pressure to the strain gauge, that its resistance will change. Easy to compensation for temperature effects, because this RG1, RG2 here, compensation for temperature is very easy, because for here temperature compensation can be done based on the arrangement of these in order to R1 and R3. Next, disadvantage is non-linear. Its our pressure will not be linear up to non-linear up to range, because sometimes if we are increasing the pressure, then the galvanometer range must be increased. No, it will be non-linear. It may be increased based on the applied. Sensitive to environmental variation, also long-term drifters there. Next, we will explain about the working principle. Huh. Right? And next, so up to here we have calculated how the pressure transmitter can work. Next topic we will discuss how the pressure can be measured in industry using the capacitive pressure transducers. What is the working? First, for measuring the temperatures, before we should know how the capacitive transducers. I think we have already discussed in our transducers class this subject, this working principle. For pressure measurement, we will see in short. Explain the working principle of capacitive pressure transducers. Okay, how will work? The principle of operation of capacitive transducers is based on the equation. This we know, we have studied our 12th standard, this equation C equal to epsilon AR into A by D. A is the overlapping area, D is the distance between the plates. Each and everything is overlapping area. Overlapping area, nothing but, suppose the two plates are there. So this is the how much area they are covering. This is the overlapping. Suppose one plate look like this, another plate was going to down. So this is area. This is a overlapping area to each other. So this is the overlap, and D is the distance between the plates. D is the distance between the plates. The D is your distance between, this is the D is the distance between these plates. This is called the D, distance between. Epsilon, this is the epsilon value is the constant. ER is a relative permeability, the electric material constant. Capacitive transducers work on the principle of change in capacitance. How capacitive transducers work on the principle of change in capacitance of capacitor. This change in capacitance could be caused by change in overlapping area. Here, overlapping area means overlapping area of plate between the distance. The working process. How they are supposed that this is the C equal to, we have seen epsilon A via D, A upon D. If we are increasing the D, then if we increase the D, then resistance will increase by increasing the D. So by if we increase, sorry, we have tell to him. If we are increasing the D, then capacitance should be reduced. If we are reducing the D, then again capacitance will increase. Based on this, in case of area, if we are increasing the area, the capacitance directly proportional to area. If we are increasing the area, capacitance will increase. If I decreasing the area, then capacitance will decrease. So this capacitor transducer using this concept. So this is the one plate here like this. This is the one plate. This is the fixed plate. This plate is fixed. This plate is fixed. This plate is fixed. And this is the another plate. This is the moving plate. This is the moving plate. This is the this plate is fixed. This is a plate diaphragm is fixed. This plate of diaphragm, these outer are fixed. Don't confuse this. This outer, if this is the diaphragm plate. This is the when pressure is applied on this, so this diaphragm plate move like this. Within that things move like this, so then this distance is going to reduce. Based on this, distance is going to reduce and overlapping area may be fixed, because so this capacitance has changed. That change in capacitance we can calibrate in terms of pressure applied. So this is the principle, how the construction and working of capacitor, how this capacitor transducers will work. So we can see the construction. This figure, the capacitor transducers has static plates. One is a static plates. This is called fixed or static plates. This static plates and flexible diaphragm. This is the deflected plates. Two plates we can make. One is a static. Second is a deflected. In case of here, this is the stationary or static plates, and this is the deflected diaphragm plate. Sometimes there is no pressure, then it will here, and the pressure is applied, it moves to here. So then distance between the capacitors will changed, and because of change in distance, and it overlapping area will be also changed. So deflection plate. So diaphragm will expand or contract. If the diaphragm expand means this plate move like this. If they expand, this will come when pressure is applied. So expand due to their change in resistance, change in pressure. These plates form a parallel plate capacitor which connected to which connected to one of arms of Wheatstone bridge. The voltage will give corresponding pressure measurement. When force is exerted to the outer side of diaphragms. So this is the constructions we have seen generally. These constructions I think we have to remove. Then we can see the construction on very easily. One static, and these plates form a parallel capacitors. These plates and these plates, these are form a parallel capacitor. It's connected to a Wheatstone bridge one. This is the whole setup is connected between this Wheatstone bridge arms circuits, and output voltage will give corresponding pressure region. According to this galvanometer reading will be changed. Initially there is no pressure, so no current will flow through the diaphragm. When the pressure is applied, then this resistance value will change, the capacitance value will change here. If the capacitance value changes, this reading of galvanometer will also change. So simple working principle, very simple. When force is exerted to the outer side of diaphragm, a distance between the diaphragm and static pressure plates it changes. Means this is the static pressure and this diaphragm. Force applied to this distance in G, that the changed. So D is going to, I think, reduce. The force applied, D is going to reduce. This is the D difference between the plates is D is reduced the capacitor. So the producer change in capacitance. D changes the D change. So because of D change, so capacitors will also changed. This will unbalance the bridge. That will unbalance the bridge, and output voltage is measured in terms of applied pressures. One is very simple principle. Here force of pressure is applied because of, so this diaphragm will deflect towards, so then this static plates and diaphragm plates distance will reduce. If distance is reduced, so then according to C barabar epsilon A via D, because this D is going to reduce or change, so then capacity is going to increase. So then this arms capacitance reactance will changes. Then the bridge is going to be unbalanced. Based on this, the galvanometer show the reading, and output voltage is measured in terms of pressures. In this way, we can do this function. The list of advantage and disadvantage of capacitive sensors. Well, construction is very simple. Second, construction is very simple. The cost of transducers is very low. Cost of transducers is very low, very high sensitivity, and sensitivity is very high. This is a very important sensitivity advantage. In MC question, they will ask about the sensitivity. Sensitivity very high. Cost is low. दूसरा disadvantage is this: performance affected by direct contaminants. Increase or decreasing the temperatures to a high level will change the accuracy, because of change in temperature. Because why this will happen? Because change in temperatures, the resistance resistance or capacitance will also change. Generally resistance will change, the reading will be changed. So this next class we will discuss how to measure the pressures using linear variable differential term. We have studied about the LVD in transducer detail. By using this principle, how we can measure the pressures, because this is going to become secondary transducers. So at that time we will discuss how to